Alright guys, I just wanted to get these last two examples from the notes because we didn't have enough time to get them in class. So number 5 on the back of the notes, I went ahead and labeled my equation. Remember, the number right next to the exponent is always the base, that's your b. So the a value in this case was 1. It's not really important to putting it in the calculator, but I just wanted to make sure that we're relating the equation to what the formula looks like. So to get this to fill in, I went in my calculator, y equals, and I'm going to put 0.6 raised to the x. And the x is right up here next to the alpha button. Once I've done that, I want to look at my table of values. Table is right here. It's written in blue. So I hit the blue button first and then graph, and it gives me the table of values. And I can see here where x is negative 2, y is 2.77. Okay? Where x is negative 1, y is 1.66. Where x is 0, y is 1. Where x is 1, y is 0.6. And where x is 2, y is 0.36. So my numbers are getting smaller. So that makes me think of a decay. When I look at my a value, there's not a negative sign there, so there's nothing about it flipping over. So this should look like our decay problem, where it starts off higher and goes lower. So let's graph each of these. Get where x is negative 2, and then almost up to 3. So we go negative 2, 1, 2, 3, 2.77. I'll put a point in. Negative 1, just past 1.5. I got 0, 1, 1.6, and 2.36. So I will be letting you know Monday kind of how you can determine the asymptote ahead of time before you start graphing just by looking at the equation. I'm going to tell you on this graph our asymptote is the x-axis. I'm going to highlight it there to help me see. That's going to be the line I'm going to approach but never ever cross. And I can see it starts off higher and it's coming down, so it's going to approach the x-axis but never cross it. Okay? So here's my exponential curve, and I want to answer these characteristic questions from them. So domain, remember, is your left to the right. On the left, it's never stopping going left. X's are negative infinity on the left. On the right, it's never going to stop going right, and y's are positive infinity on the right. And we use parentheses because they're not equal to. The range, there's only two choices on the range, remember. It's either the asymptote to infinity or negative infinity to the asymptote. So asymptote to infinity or negative infinity to the asymptote. Okay? Well, when I look at this, and I start at the bottom of my graph, because we always read range bottom to the top, there isn't anything until I get to the asymptote, which is where y is 0. And from there, it continues going up forever into infinity. So this range will be 0 to infinity. You can't be equal to 0 because that's the asymptote, and you can't be equal to infinity. So they're both parentheses. As I go from left to right, my graph is falling, so it's decreasing. It is a decay graph. If I check my b value, it's between 0 and 1, which means this is a decay. Okay. There is, in this case, there's no x-intercept because the x-axis is the asymptote, so we'll never touch that. So we're going to write not any in there. The y-intercept is always where x is 1. There it is in our table of values, or we could read it off the graph. And then the asymptote, we said it was already 0, but it's actually the whole line here. So we want to write it as y equals 0. So we have the proper equation for that horizontal line. So we go through, we make sure all these are right, and then we'll do the same thing for problem number 6. So let's make some predictions on problem number 6. I've labeled A. Well, A is my y-intercept, so my y-intercept is actually going to be at 0.9. So I could, right now, I could do that if I wanted to, okay? And I'm telling you today that in this graph, this is the asymptote. I'm going to highlight it so I know I'm not going to cross over that line. Monday we'll learn how to identify the asymptote from the equation. So I want to get the rest of these values. I'm making some predictions before I graph. This value is positive, so I know it's above the asymptote. It has not been reflected over. My B value is more than 1, so that means I'm going to have a growth, and if I have a growth, it's going to be increasing. Okay, so let's take this and we're going to put it into our calculator. I'm going to clear out the old equation, and I'm going to start the same way. I'm in y equals, and I'm going to put exactly what I see. I see 0.9 parenthesis 8.4 close the parenthesis, and then remember you got to use your little up arrow to get into the exponent, and the x is right next to the alpha button. I could look at the graph, but really what I'm interested in right now is the table. Table's written in blue, so hit the blue button, then that to get to the table of values. At -2 equals 0.0128, okay? -1 is 0.1071. 0 is 0.9. Well, there's that y-intercept we just named. And 2 is 7.56. And, 1 is 7.56, and 2 is 63.5. Obviously, we are not graphing that point. We do not have enough room on our graph for that. So we'll just graph what we can, and we'll kind of follow the lines along. So -2, and it's just barely up. So I'm just going to kind of put a point right above the x-axis. -1 is a little higher up. Okay. 0 is at 0.9, so it's not even a whole lattice up. 1 is 7.56, so we're going to go 7, 1, 2, 3, 4, 5, 6, 7, and halfway to the next. And then the next one's way up off. We can't see it. So I'm just going to, I know this is a curved graph, so I'm going to kind of follow the curve to make it happen. And there we go. He's really steep on this one. So domain, this is not a real world problem, so I was having you put arrows on both ends. We'll talk about real world eventually. So to the left, it's never ending. So on the left, we're going to have negative infinity. It's never ending on the right, so it's positive infinity. My range, I read from the bottom of the graph up. When I read from the bottom, the first thing I hit is the asymptote, which is at 0, and it continues on forever and ever into infinity. Okay. We already made these predictions. It is in fact increasing, and it is a growth. The x-intercept, well, the x-axis is the asymptote, so we can't ever touch it. So we're going to say not any here. And then my asymptote is the x-axis, which is where y equals 0. So hopefully this will help you as you do these 4 homework problems. Have them due on Monday so we can talk about them, and have a great weekend.